Complete solution of mathematics for class 10 under the syllabus of Board of Secondary Education Manipur. All recorded and edited by I. Salame Gasindra Singh, lecturer, Sursan Higher Secondary School, Imphal. Mensuration. Conversion of solid from one shape to another. Solid figure ama atopa figure singda onba. Exercise 12.5. Question number 1. A solid cube is cut into two cuboids of equal volumes. Solid cube amakak manaba volume manaba cube anida kakatli. Find the ratio of the total surface area of the given cube to that of one of the cuboids. Find the ratio of the total surface area of the given cube to that of one of the cuboids. Surface area, total surface area cube is 2 cuboid adu putu haven. Let the each of the cube be x, then the dimensions of each cuboid are x by 2 into x into x. The total surface area of the cuboid is cube 6x square. Cube amagi formula cube amagi surface area putokpagi formula di side amagi 6 times of side amagi square ne. The total surface area of the cuboid. Cuboid adugi surface area the total surface area of a cuboid is 2 times x by 2 into x plus x into x plus x into x by 2. Cuboid amagi total surface area putokpagi formula di 2 times of length plus breadth is plus is L haibasini. Pansilaga receive hangani. Simplify taro for x square. Thus the required ratio D cube is to cuboid having 4x square divided by 6x square divided by 4x square, that is 3 by 2, that is 3 is to 2. Question number 2. A sphere has the same surface area as the curved surface of a cone of height 16 cm and base radius 12 cm. Find the radius of the sphere. A sphere has the same surface area as the curved surface area of a cone of height 16 cm and base radius 12 cm. Sphere amagi surface area si manai. Kanaga sphere amagi surface area si cube amagi surface area cone amagi surface area. Cone amagi surface area ga mane karamba cone hairagadi cone dugi surface area du karamba kono hairagadi magi height amasu radius pirame. Maha ke height na 16 ni radius na 12. Sigi sphere sigi surface area siga sigi cone sigi curved surface area ga ani si manai haina pirame. Then find the radius of the sphere. Sigi radius to r asi what hangman. For cone r is 12 cm, height is 16 cm. So slant height L is this is slant height. Then this is 16 is is and this is r. Applying Pythagoras theorem, we get giving their respective values and solve. We have 20. Let capital R be the radius of the sphere. By question, surface area of the sphere is given as equal to curved surface area of the cone. Surface area of the sphere the 4r square ni curved surface area of the cone the pi rl ni. That is 4 pi r square pi rl. Giving their respective values, small r da capital R visual ni. Then pi kakakaba matungda r gi value the 12 ni. Aduga L slant height 20 ni, from which we have r square is 60. Therefore r is 2 root over 15. Thus the radius of the sphere is 2 root over 15 cm. Question number 3. A solid metallic cone is it 1 cm high and radius of its base is 6 cm. Solid metallic cone amakaki height asi 81 centimeter pirame, radius na 6 pirame. If it is melted, masifam sogdokale and recast into a solid sphere semi. Find the curved surface area of the sphere. Adugumba mangondagi semba solid sphere adugi curved surface area. Solid curved surface area of the surface area. Surface area adugi sphere adugi surface area puto. For the metallic cone R is 6, ice is 81 centimeter. Let R be the radius of the sphere. Adugumbi sphere adugi radius ado capital R lauxile. Then the volume of the sphere is equal to volume of the coil. Volume of the sphere is 4 by 3 pi R cube equal to volume of the coil is 1 by 3 pi R square ice. Common 3 kathana kare we have the ice ki value the 81 pirani, R ki value the 6 pirani. Then R cube is this. Then R is what? R is 9. Kisi ki capital R is 9 or 9 or any. Find the surface area of the sphere, curved surface. Thus, the curved surface area of the sphere is 4 pi capital R square. Giving their respective value R and 9 pisin gani. This must be 9. We have 1018.29 centimeter square fangani. Question number 4. A solid metallic sphere of diameter 28 cm is melted and recast into a number of coals, each of diameter 7 cm and height 4 cm. Find a number of coals so formed. Solid metallic sphere ni diameter kaya oiba diameter adu 20 ga 8. Diameter adu 28 oiba. Sigi diameter C 28. Recast into a number of coals ni coal masa masa mayam ama same. Karamba coal number coal is of diameter sigi diameter say 7 cm. Height na 4 oiba. Find a number of coals. That is volume of the sphere is 4 by 3 pi R cube. Simplify Torah, we have this volume of a coal this in it. The total number of coals, the volume of sphere, the volume of one coal na yelani, we have number of coals that is 224. Find the number of coals so form, a number of coals so form is 224. Question number 5. The internal and external radii of a hollow metallic sphere are 3 cm and 5 cm respectively. Hollow metallic sphere amakak anikak amana radius 3, amana radius 5. If the sphere is melted and recast into a solid cylinder of height this asigumba sigi solid sina metallic kano sina sphere sina sogdolaga recast aure cylinder amakak seme solid cylinder amakak seme. Maha ke height asi 2 whole 2 by 3 cm. Find the curved surface area of the cylinder. Cylinder ki curved surface area putu. Madhugi the makta di radius sigi cylinder sigi radius mathokta. Sigi cylinder sigi radius 1. Volume of the hollow metallic sphere, the sphere volume of the outer sphere minus volume of the inner sphere. That is outer sphere the 4 by 3 pi R cube. R cube, that is this. Simplify Torah. Let R be the radius of the cylinder. Cylinder radius to R oxalasi. Then anisi volume anisi mana gadabani volume anisi mana radadi cylinder ki volume di pi R square into ice the 6 to 3 to 6 to absolute 8 by 3. Then 4 by 3 pi sigma nahalani. We have simple pi katha karne R ki value dot 7 pange. 2 nasi already 49 7 square. Radius to cylinder. Then surface area, curved surface area of the cylinder is twice by R ice ni. Respective value simplification law, ice ki value the R ki value the 7 and ice ki value the I by 3. Simplify Torah, we have 117 whole 1 by 3 centimeter square. Question number 6. A metallic cone of height 28 centimeter and radius of base 12 centimeter is melted and recast into a cylinder of height 9 whole 1 by 3 centimeter. Find the curved surface area of the cylinder so formed. Metallic cone of height 28 centimeter. Metallic cone. Height 28 centimeter ni radius ne 12 ne. Recast into a cylinder ama same cylinder ama. Height cylinder to get height to 9 whole 1 by 3 warani. Adu warabadi find a cup surface area. Cup surface area of the cylinder putoke di asi RG what tarani. The volume of the coil is 1 by 3 pi r square is. Which is this? Let r be the radius of the cylinder. Then volume of the cylinder equal to volume of the coil, from which we have to solve capital R, that is 12. A capital cylinder की radius is 12 और है. Thus the curved surface area of the cylinder is twice pi r into is. Simplify, we get 704 centimeter square. Question number 7. 20 circular plates, each of radius 7 cm and thickness 1.5 cm, are placed one above another to form a solid cylinder. Find the curved surface area and the volume of the cylinder so formed. Asugumba cup plate mayama same size ki. Longkhaneraga machine cylinder ama same. Hariba Shigi is radius same radius is 7 cm ni thickness ta 1.5 cm ni. 20 circular ni sidagina C box say 20 ni 20 plate. Find the curved surface area and the volume of the cylinder so obtain haragadi. Then for the cylinder radius is 7 cm, height is 20 into 1.5 cm, that is 30 cm. So the curved surface area of the cylinder is twice by Ri. Respective value simpiro we have that is is the 30 ni 1320 centimeter square. Volume the volume of the cylinder is pi r square is pi r square is 30. Solving we get 4620 centimeter cube. Question number 8. Find the volume of the largest sphere that can be carved out of a cube of side 4.2 centimeter. Cube amadagi karamba cube 4.2 centimeters na side its pivan amagi asang boiba side amagi asang boiba cube amadagi khwaidagi chawba sphere amakak lawthokse cup out tawthokse lawthokse adugumba volume anido compare tawnaw haibani. The volume sphere amakak happer chawba sphere amakak. The diameter of the largest sphere, the each of the cube, that is 42 centimeter. 4.2, it must be 4.2. Then so the volume of the largest sphere that can be carved out of the cube is 4 by 3 pi r cube r kayano 2.1. 4.2 the 2 ni yellow body 2.1 lere cube learning. Simplify to we have 38.81 centimeter cube. The volume of the cube T side omega sang cube ni we have this. So the required ratio D Canada volume of the cube ta volume of the sphere and volume of the cube ta volume of the sphere ni yellow we have 42, that is 21 is to 11. This is the required ratio. Question number 9. Find the volume of the largest cone that can be carved out of a cube of side 16.8 centimeter. The diameter of the cone, the its of the cube ne. There is its of the cube is 16.8 centimeter ne. So the radius of the cone adu is 16.8 centimeter to tuni yalabadi 8.4 centimeter phangani. Height of the cone its of the 16.8 centimeter orani. So the volume of the largest cone 1/3 pi r square is r value the 8.4 pixel. Then ice ki value is 16.8 simplified to we get 1241.86 centimeter square. It must be cube. It must be cube. Question number 10. At solid cone of diameter 14 centimeter and height 8 centimeter is melted and recast into a hollow sphere. If the external diameter is 10 centimeter, find the internal diameter of the sphere. A solid cone of diameter 14 diameter solid cone. Solid cone of diameter 14 centimeter. Diameter 14 centimeter. Height is height 8. Melted and recast into hollow sphere. If the external diameter is 10 centimeter, find the internal diameter of the sphere. Sphere amakak machine sphere amakak semi hollow sphere amakak that is external diameter duna 10 ohele internal diameter do kaya oigadage. The volume of the cold 1/3 pi r square is. We have this. Let capital R and small r be the radii of the external and internal spheres. Then R is what? R radius ni. Radius ti 10/2. External into 10 ni. External ki diameter na 10 already. External into ki radius ti 5 centimeter ni. By question, the volume of the hollow sphere equal to volume of the coil. Volume of the hollow sphere to the 4/3 pi 5 cube minus r cube or any volume of the coil 1/3 pi r square is. Solving, we have r equal to 3. The diameter of the inner sphere to the twice r diameter or radius kanga the radius the 6 centimeter again. Question number 11. A hemisphere of lid of radius 7 cm is cast into a coil of base radius 3.5 cm. Find the height of the coil. A hemisphere of lid of radius 7 cm is cast into a coil of hemisphere amakak. Hemisphere amakana coil amakak semi. Coil amakak semi. Height of the coil do puto animal volume man hangani. Hemisphere to radius to the 7. Putting 7. Here volume of the hemisphere is 2/3 pi r cube. We have this, and let h be the height of the coil. Coil to the height to h locality by equation. Volume of the coil equal to volume of the sphere. Volume of the coil is 1/3 pi r square is aduga. Hemisphere ki volume is 2/3 pi 7 cube. Solving h we have 5.6 centimeter. Thus the height of the coil is 56. That is 5.6 centimeter. It must be 56. A cylinder is cut lengthwise and flattened, thereby forming a rectangular of dimensions 66 cm into 28 cm. Find the curved surface area and volume of the original cylinder. Let R and H be the radius and height of the cylinder. Then the circumference of the base of the cylinder is 66 centimeter. That is circumference of the base of the cylinder adudi twice pi R equal to 66. R value to 10.5 centimeter. Also ice is 28 centimeter. So the curved surface area of the cylinder is twice pi R into I. We have 1I4I centimeter square. Also the volume of the original cylinder is pi R square I. We have 9702. Question number 13. A sector of a circle of radius 6 centimeter has angle 120 degree. Circle ama radius 6 centimeter oiba circle amagi center semi angle C sectorial angle C 120. This is 120 degree. Radius to 6 ne. If a sector of a circle of radius 6 centimeter has angle 120 degree. It is the roll up so that two bounding radii are joined together to form a cone. Sigi kano sina sector sina semaga cone ama seme. Find the volume of the cone. Let R be the radius of the cone. Adugumba sina semokpa cone adugi radius to reduce. Let then slant height of the cone L equal to radius of the sector. Radius of the sector sigi radius to sigi slant height to the sigi 6 orani. By question the curved surface area of the coal dugi curved surface area of the sector ga manarani. Then curved surface area of the coal pi R L ni area of the sector d pi R square into theta by 360. And rest giving pi kakakro L give value 6 pisilo R value 2 phange. Find the volume of the coal. So the height of the coal is coal height to the Pythagoras theorem palavadi is equal to root over L square minus R square. Giving respective value and solve, we get for 5.6 centimeter. So the volume of the coal is 1 by 3 pi R square ice. Respective value PCLC solve to ice की value do 56 5.6 ice की value do 5.6 होएगा तो then 23.47 centimeter cube होएगा तो. Question number 14. A conical flux of radius x units. Conical flux of radius 6 units and height 20 twice x units and height twice x units is full of water. The water is poured into a cylindrical flux of radius twice x by 3 units. Find the height of the water in the cylindrical flux. Conical flux. Conical flux to radius to x lower height na twice x sorry. Full of water ni isi cylindrical flux amada haijale. Cylindrical flux amada haijale. Karamba mahaki radius to sigi radius hai twice x by 3 wangba. Radius oiba height of the sigi cylinder is the cylinder sigi height to height. Let the height of the water be ice. The volume of the cylinder equal to volume of the coal. Volume of the cylinder is pi R square into ice. And the volume of the coal is 1 by 3 pi R square ice. Simplify, we get ice equal to thrice x by 2 units. Question number 15. The radii of the bases of two solid metallic coals of same height ice are x1 and x2. If the two coals are melted together and recast into a cylinder of height ice, then show that the radius of the base of the cylinder is this. Height ice oiba radius na x oiba. Coal anikak melted tore and recast tore. Sigi height sina ice radius na x1. ꯑꯇꯣꯞꯄ ꯀꯣꯜ ꯑꯃꯁꯨ ꯁꯦꯝꯁꯤ ꯑꯇꯣꯞꯄ ꯀꯣꯜ ꯑꯃꯁꯨ different sizes ni maramdi x1 amasung x2 manadaba cases ice oigani sidana x2 oigani ani si punjalani aduga amuk cylinder ama semani karamba cylinder aduga height ice of cylinder ama seme sigi radius of the cylinder sigi base sigi radius part then so the cylinder si oigani have a radius to let R be the radius of the base of the cylinder, then the volume of the cylinder equal to volume of the two coils. Then volume of the cylinder pi R square is the volume of the two coils to the anisilirani. And simplify to we have to solve capital R. Capital R solve to square root of 1 by 3 R x sida R1 so R2 singa se x1 so x2 sinjalo sigi x2 sinjalo with this x. This x oigado. Hence pro. Question number 16. A solid metallic cylinder and another solid metallic cone have the same height as and the same radius r. If the two solids are melted together and recast into cylinder of radius half r, prove that the height of the new cylinder is 16 by 3 times of s. Solid metallic cylinder amaga atopa coal amaga solid metallic cylinder. Siso height ice ne. Coal amaka ka height ice over coal amaka ka same. Siso ice ne. Of radii, siso radius, sig radius later. Same height ice same radius, siso radius r ne. Ani recast or cylinder ama same. Cylinder achoba cylinder ama same ne. Sigi radius to sigi radius se kaya hoigani half of r or. Sigi height to the height of this new cylinder sigi height se prove that 16 by 3 times of ice. Let capital H be the height of the new cylinder by question volume of the new cylinder equal to volume of the cylinder plus volume of the coil. Volume of the volume of the new cylinder the pi r square is equal to volume of the Hanagi cylinder pi r square is. Then volume of the coil 1 by 3 pi r square is. Simplify, we get capital H equal to 16 by 3 times of small h. Hence proof. Question number 17. Two solid metallic cuboids of dimensions these are melted together and recast into solid cubes, each of side 5 centimeter. Find the number of solid cubes so formed. Volume of the two cuboids still LB is palani. We have this. Volume of a cube of side 5 centimeter. The L cube there is 5 cube. That is this. Let n be the required number of cubes. Then 125 into L equal to 1000. From which n equal to this. That is I. Thus, 8 solid cubes can be formed. Question number 18. A sphere of diameter 6 cm is dropped into a cylindrical basin partly filled with water. The diameter of the basin is 12 cm. If the sphere is completely submerged, how high will the level of the water be raised? A sphere of diameter 6 cm is dropped into a cylindrical basin. Cylindrical basin amada. Cylindrical basin amada 6 cm na diameter oiba sphere amakak. Completely 6 centimeter na diameter oiba. Completely is the local. The diameter of the basin is 12 centimeter. Diameter of the basin, sigi diameter, sigi basin, sigi diameter say 12 centimeter ne. If the sphere is completely submerged, find how high will the level of the water. The volume of the sphere is 4 by 3 pi r cube. Read this. Let x centimeter be raised of the water level in the cylindrical basin. Then volume of the cylinder equal to volume of the cylinder equal to volume of the sphere. Then x equal to 1. Volume diameter of the basin is 12 centimeter. The sphere is completely submerged. How high will the level of the water rising? This is pi r square. Volume of the cylinder is this. Mark hangale let x centimeter rise to the water level. Sigi volume hangala kiba isingi volume duga ya kakala kiba isingi volume matek tu isingi volume matek duga sigi volume sigi water siga volume is sphere ga mana halaga x put a 1. Thus the level of water in the basin will raise by 1 centimeter. Question number 19. A solid metallic cylinder of radius 14 centimeter and height 21 centimeter is melted and recast into a number of spheres, each of radius 3.5 centimeter. Find a number of spheres so formed. Metallic cylinder. Solid metallic cylinder of radius C 14, height 21, melted and recast into a number of spheres. Sphere kaya marum tono same. Sphere to give radius to 3.5 centimeter over. Find a number of spheres of them. Volume of the metallic cylinder is pi r square is giving respective value, and volume of the sphere to the 4 by 3 pi r cube. Let n be the required number of plates. Then n into this gives equal to volume of the sphere cylinder, from which we have to solve n. N value kaya pange, we get n equal to 72. Thus the number of spheres so formed is 72. Question number 20. A spherical shell of lead whose external diameter is 16 centimeter. External diameter C 16 centimeter ne recast into cylinder of height. Cylinder of same go height to 9 hole 1 by 3 centimeter. And a diameter C diameter aduna 16 centimeter. Find the internal diameter of the cell. The cell dugi internal diameter putu C diameter se what number? Anisi managani. Solution. Let R be the internal radius of the cell. The volume of the cell to the 4 by 3 pi outer radius to the 16 give the height lerani. Then radius to R equivalent. Volume of the cylinder pi r square is anisi manarani recast or melted and recast on r value solved or r value do 8.4. The required internal diameter of the cell twice ani, that is 8 centimeter. Question 21. A basin is in the form of an inverted cone of height 8 centimeter, height 8 centimeter and radius 6 centimeter. It is filled with water up to the rim. When lid shorts is of which is a sphere of radius 0.2 centimeter are dropped into the basin, 1/6 of the water flows out. Find the number of lid shorts drop out into the basin. For the conical basin, radius is 6 centimeter, height is 8 centimeter. The volume of the basin that is cold 1 by 3 pi r square is giving their respective values. We had 96 pi centimeter cube. Volume of a lid short to the 4 by 3 sphere ni lid short to the sphere sphere. We have this, solve this. Let n be the required number of lid shorts. Then total number of n lid shorts the 1 by 6 of the volume of the basin. Volume obviously the total number of n lid shorts to the n volume of the one source to Purinani Then 1 by 6 volume of the basin is 96 pi or simplify we get N40I. N40I that is smooth divided over 1500. Hence the required number of lead source is 1500. Question number 22. Water is flowing at a rate of 5 km per hour through a pipe of diameter 14 cm into a rectangular tank of base 30 meter by 22 meter. Find the time during which the level of water in the tank rises by 35 cm. Here the speed of the water in the pipe is 5 km per hour. That is meter per hour. So volume of water through the pipe in 1 hour is pi r square ice. That is pi 22 by 7, r is 7 by 100 whole square, ice is 550 Marie. This is 0, this is 40. 1000 of 5 to put it, it must be 0 ohm. 0 ohm, 0 ohm. Simplify, we get 77 meter cube. Volume of water in the rectangular tank when the level of water raised by 35 centimeter is 30 into 22 into 35 by 100. That is 231 meter cube. The required time taken, the 231 divided by 77, that is 3 hours. Thanks for watching.